Here we have the Stierli bender with the Siemens Touch control. This is a 2-axis bender with programmable back gauge and programmable ram. It allows you to either bend manually with stroke only dimension, or since it's a CNC control, we're allowed to program angle bending based on tooling, library, and material thickness. This is a closer look at the Siemens Touch control for the Stierli bender. This machine has 4 menus that we use to control all aspects of the machine's operation. After we first turn on the machine, the first thing that is necessary to complete is calibrating of the system axis of programmability. We have back gauge that we need to calibrate, and also we need to calibrate the ram. It's important to note that before you can calibrate the ram, we have to push the hydraulic on button, and I'll do that at this point to start the pump. We'll not calibrate until we have that pump running. So, calibrate the axis, we merely touch the menu, and we have a sub-menu that consists of back gauge calibration, both starting the calibration and stopping the calibration, and tap allows us to move the back gauge manually, both at a slow and rapid jog. Then we have to calibrate the cylinder axis, this row, and that's done by driving the ram all the way to its full retract position and touching the 0 key. So the first thing we're going to do is press our start, and the back gauge goes to the calibrated distance of 16.54 inches, and the LED in the start key will turn green, indicating that we've got it calibrated correctly. Next thing we're going to do is we're going to drive the cylinder all the way to its rear position. We'll hear a little bit of a strain on the cylinder, and then we press the 0 key to calibrate. We also get an idea of what the current location of both the back gauge and the cylinder is by these DROs in the calibration screen. We'll escape back to the main menu and cover some of the other features of the controls menu. First, we have the setup screen, settings screen, and that allows us to adjust basic parameters of the machine, things like retraction distance, inches or metric programming. All of that can be done in the settings. It isn't normally accessed during the day. It's set once and then pretty much forgotten. Bottom left-hand corner of the screen is the bending menu structure, and that allows us to create both manual single bend programs or multi-step programs that can be programmed either by stroke or angle based on the tool library in the machine, of very explicit dimensions of those tools, and the material thickness. The last menu selection we have is the straightening menu in the lower right, and the straightening menu allows us to create a program to straighten things like rails, any long things that have a curvature that needs to be taken out. And that's just a basic 3-point tool setup, and allows us to manually press on, or excuse me, programming a series of presses on the rail to take the curvature out. So, the thing that we're going to try to accomplish in this video is just show a very basic program creation for a multi-bend program by angle bending. So, I'm going to select bending from the menu, and I'm going to create a bending program, which is a series of bends. If I chose to do manual bending, I can select the left-hand tab, and that allows me to create a program either 1, 2 bends. You wouldn't want to do any more than a couple of bends. That can be executed but not saved. The bending program is multi-step bending program, either stroke entry or angle bending, that can be saved to a program number 1 through 200. And we have tool management on the far right. Tool management allows us to define very critical dimensions on both the punch and the die, and that can be used to calculate the desired angles based on material thickness while we're creating the bending program. So I'm going to go ahead and select bending program. It asks me to confirm whether I want stroke entry or angle entry. Angle entry is by far the easier of the two. Stroke entry, you would have to calculate through test bends the appropriate distance from 0 that the stroke of the ram has to extend to in either inches or millimeters to create the desired bend. So we will choose the easier of the two, angle entry. And the next thing that it's going to ask us is what tooling are we going to be using? The first tool that we have to indicate is the punch. The punch that we have loaded now is a 22.35 nose radius, so that's already highlighted in default. I'll select it. Next thing I want to just confirm is the material thickness. I can enter whatever I'd like. This particular material thickness, I believe, is 0.62. So let me clear that out. 0.62 and enter. Next thing I'm going to have to indicate is what V block I'm going to be using. And I have a V block that's 125 millimeters across the shoulders, 87 degree included angle. That's already loaded in my out library. So my bending program screen, I'll describe quickly. The top left entry is my program number, and again that's 1 through 200 on this particular control. My middle top window is the edit to number. That basically lets me define how many of those steps in this program I want to run when I switch over to automatic mode. So I could have an 8-step program and I could choose only to run the first bend, and I could then enter that bend number 1 to limit the program running to only that first bend. I'm going to wait until I have the program completed and then enter the last line, last bend number in this to complete all the steps. Far right up here at the top is the quantity of these programs parts I want to run. In this case I'm going to leave it at 20. It'll complete 20 pieces and then stop. So to enter a program, all I do is enter the bend number, back gauge position, and the angle in the cylinder X in degrees. I also have a correction factor in the far right hand column that I can correct for deficiencies of the actual bend after we've run the program once in a sample piece. And all I will do is go through and indicate each subsequent bend on steps 2, 3, 4 until I have the program completed. After that, I will indicate my pinch point down here in the lower midsection of the window, and also my retraction point here in the immediate right of the pinch point. After that, I can hit start here, the second function key, and that will initiate the program running. So I'm going to go ahead and enter all desired bends, and let's say I'll enter 3 bends. First back gauge position, let's say, is going to be 6 inches, for example. I enter 6.0 and hit enter. Next, I give it an angle of 90 degrees. Enter. So I've got my first bend completed. The yellow tab out here to the far right column is the stroke that it calculated based on the punch and the die as well as the material thickness I called out in the previous screen. So that's how it comes to an actual number for the stroke. It uses all of those relevant dimensions from tooling and material thickness to calculate that number for you. So now I'm going to come down to bend 2 with this down arrow, and I'm resting on bend 2, and now let's say I'm going to go to 11.5 inches with an angle of 45 degrees. Yep. I've got that bend defined now totally, and we see it came up with a different ram location here for 45 degrees. Again, all calculated for you based on punch height and angle, nose radius on the punch. On the die, we've got distance across the shoulders, the shoulder radius, and the included angle of the die. Those are the only three bits of information you need for both the punch and the die. That being calculated, I can go on to step 3, and I'm highlighting step 3 now, and I'm going to enter a back gauge position of 18 inches and an angle of 90 degrees. Oops. If I make a mistake, I just backspace, type in the 90 degrees again, and hit enter. Okay, I've got everything done as far as the back gauge positions and the angles that I want to bend. Okay, to define the pinch point and retraction point, we have to highlight in the last bend, bend 3 here, the left box of the angle column. That will let the control know that I'm ready to define the pinch and retraction points. Notice that the pinch and retraction points are both still red. We have to turn those green, and that will indicate that we've successfully defined those 2 points prior to running. The control has to have that bit of information, has to have a pinch point and a retraction point. Failure to do so might get your program not to run too correctly. So we've got to define those 2 things. So we're going to define pinch point and retraction point now by first coming forward with the foot pedal with the tooling. We have to have a piece of scrap material in the tooling at this point, but we're going to do it this way without material just for demonstration purposes. We come forward until that V-block just pinches the material. We'll call it there. And at that point, we're going to come over and press our F3 pinch point button. At that point, that LED turns green, indicating that we've successfully defined that pinch point. Next thing we're going to do is use the arrow push button on top of the electrical cabinet to come back to a retraction point that we want to define. And if that's the retraction point we want to set, then we would hit F4 to define that retraction point. Both LEDs F3 and F4, the pinch point and retraction point, are now green. We're ready to start the program. When I hit start, F2, the control automatically comes back to step 1, bending step 1 in the program. To complete the program, all I'll do is tap the foot pedal once, and the back gauge comes into the first location, being 6.0 inches. I'll pan down just a little bit so we can see the back gauge position. Now I'll press and hold the foot pedal while the tooling comes forward to make the bend. It's important to remember that you hold the foot pedal down to complete the bend. Otherwise, if I release that foot pedal prematurely, the V-block will retract and you won't proceed on to the next bend in the program. So I'm going to hold my foot pedal down. The tooling retracts or advances until it gets to the pinch point. The back gauge pulls away to a retraction point and the bend is completed. I can release the foot pedal now as the V-block pulls away from the punch, and the machine is in a hold pattern until I tap the foot pedal again. I tap the foot pedal again, as I said, and the back gauge goes to the second location, which is 11.5 inches. The machine is now waiting on me to complete the second bend to 45 degrees at that 11.5 inches. So I'm going to hold the foot pedal down. Here's an example. If I let up early, the tooling retracts without going on to bend 3. It knows that I interrupted and didn't complete bend 2. So I'm going to hold down the foot pedal to complete bend 2. The back gauge pulls away to its retraction location. Again, that's set in parameters. And the machine completes the 45-degree bend. Now, the control, I'll pan up here a little bit. I don't know if you can see it, but the control has already advanced to step 3. And it's waiting on me to tap the back gauge to go to that last location of 18 inches. So I'm going to pan around and down to show the back gauge again. Widen out. And I'm going to tap the foot pedal once. The back gauge goes to 18 inches. And now it's waiting for me to press and hold the foot pedal to complete the bend. This bend is going to be at 90 degrees, so it's going to go to the deeper stroke of 6.205. As a note, 6.205 is the distance from the 0 point of the ram, which is full retract, in inches, out to the point that it needs to come to make the 90-degree bend in this bend. Again, that is a calculated position based on tooling height, tooling nose radius, and tooling shoulder radius and included angle. I'm going to pan back up after that third bend was completed to show that the control has already reset itself back to bend 1, and the machine is now back in a position where we are ready to start the program over again and complete all 20 pieces. Again, it will go 20 pieces and then stop the programming running automatically. Okay, what we have here is the Stierli offline programming software for the Siemens control. We have a section across the top is our menu structure, and we can create both stroke bending programs and angle bending programs, as well as edit our tooling, and that all can be loaded and retrieved from the machine. So, as an example, I'm going to edit a bending program with this tab. I get a box here that displays all of the programs that are stored offline, along with a 20-character program description, which could be a part number, details about the program, which would jog your memory about which one you want to load. Once you see the one you want to load, you just highlight it and hit enter. I'm going to load number 1 and come down here and click the Open Program tab. We have a series of bend numbers across the left column. Then we have our back gauge position in the second column and our angle in the third column. We also have the adjustment compensation out here in the right-hand column, that once we do a test bend, we can factor in any compensation. Once that program is created here, we can load it to the machine at any time. So it gives you a lot of flexibility about staying offline to create programs while the machine is still running production. So a very valuable tool to maximize the production. Very easy to use because we're programming it exactly the way we program